As we have just learned, some of the protons pick up energy and go from a lower to a higher energy level, thus decreasing magnetization in longitudinal direction. But something else happens. Do you remember what drawings of radio waves look like? They resemble a whip. And what does a whip make the bears do? It makes them walk in line, in step, in sync. They are in phase. Believe it or not, the RF pulse also has a whip-like action, not on bears, but on protons. When the protons randomly point left, right, back, forth, and so on, they also cancel their magnetic forces in these directions. Due to the RF pulse, the protons do not point in random directions anymore, but move in step, in sync. They are in phase. They now point in the same direction at the same time, and thus their magnetic vectors add up in this direction. This results in a magnetic vector pointing to the side to which the precessing protons point, and this is in a transverse direction. This is why it is called transversal magnetization. In summary, the RF pulse causes longitudinal magnetization to decrease and establishes a new transversal magnetization. This newly established magnetic vector naturally does not stand still, but moves in line with the precessing protons and thus with the precessing frequency. The situation can be compared to a ship. Think about the passengers being distributed randomly all over the deck. The ship is then in a normal position. Then have all the passengers walk in equal step around the railing. What happens? The ship leans towards the side where the people are. A new force is established and becomes visible.